What's up? Welcome back. If you're not subscribed, consider getting subscribed, but today we're going to take a look at another air cooler from our buddies over at Scythe. This cooler is the Scythe Fuma 2, and it's Scythe's newest air cooler in the Fuma family, and with this new air cooler comes some new design stuff like asymmetrical design and what Scythe is calling dual fan reverse flow. This is intriguing. Now, if you're a subscriber to my channel, you know that I've been kind of messing around with the idea of building or designing and 3D printing my own 120mm fan. So when I saw this dual fan reverse flow called out on this air cooler, I was like, what? And then I knew that, just throwing this on my test bench, testing it out, wasn't really gonna be enough. We're gonna have to dive in a little deeper to see exactly what this is all about. However, before we dive down that rabbit hole, let's talk a little bit about the cooler itself. The Fuma 2 is a twin tower design, asymmetrical profile air cooler, and simply put, that just means the fin stack is not above the CPU socket. Doing this provides the maximum amount of space between the fin stack and the motherboard DIMM slots, so you don't have to worry about any interference issues. And I know what you're thinking. You're like, I have DIMM slots on both sides of my CPU. Are you telling me
I can only use 4 of them?
No, I mean, that would be really funny, but this isn't Scythe's first rodeo, and they made sure to consider this when they designed the cooler. On the rear tower, they made sure to design the cooler in such a way that, it can clear any DIMM slots on the backside. They put you a nice big cutout, so no worries, you're not gonna have any problems. Through this fin stack travels 6 6mm heat pipes connected to a solid copper base plate, all of which are nickel plated. The cooler itself, with fans installed, measures 130mm wide, 131mm deep, and stands 154.5mm tall from base plate to the tip top of the heat pipes. And in typical Scythe fashion, the top fin of each of the fin stacks gets a nice black anodized finish, which I personally like, and they do it on all their coolers, and it just adds a little bit extra to how the air cooler looks, and I appreciate it. The Fuma 2 uses the Hyper Precision Mounting System 3, which is compatible with just about every mainstream socket out there. The system ensures even, balanced pressure distribution and easy installation. The cooler ships with 2 Kaze 120mm fans, one 15mm slim, it's a little tiny guy, and then a standard 25mm. Also, Scythe went ahead and threw in some extra fan mounting hardware just in case you want to mount another fan on the backside for some added power. But it's not even the most interesting part. These fans aren't your typical dual fan configuration you're gonna see on other air coolers. This configuration is what Scythe's calling the dual fan reverse airflow. And what that means is that basically the fans spin in opposite directions. The Kaze 120 Slim spins in the normal counterclockwise direction, while the thicker 120, the 25mm guy, that one spins clockwise, which is pretty rare among PC fans if you've looked at any 120mm fan out there. The claim Scythe makes for this contra-rotating configuration is that doing this creates higher static pressure and an increased and more stable airflow. And this is what I alluded to at the start of the video. This is something we're gonna have to take a look at. We're gonna try to visualize and test both of these claims and kind of see what they do before we throw this on my test bench and see how it performs. Now, I know what you're thinking. This contra-rotating configuration sounds like a load of marketing BS. But the idea of contra-rotating propellers really isn't a new one. Contra-rotating propellers have been around and tested for a long time, mostly in the aviation world, and it works something like this. Air flowing through a propeller disc creates a significant amount of rotational airflow. This rotating air is essentially wasted energy. However, what engineers discovered is that if you place another propeller right behind that propeller, but spin it in the other direction, it can take advantage of all this disturbed airflow. Meaning a well-designed contra-rotating propeller will have no rotational airflow, pushing all that air uniformly rearward, resulting in a higher performance and a lower induced energy loss. Fun fact is, contra-rotating propellers have been found to be between 6 and 16% more efficient than just normal single propellers. Also, one of the most well-known aircraft to use this design, still flying today, is a Russian Tu-95 Bear. However, nothing good comes without trade-offs. The biggest ones being noise, and along with that is their increased complexity versus like a single propeller. And those two together is why you don't see more of them used in the aviation world. But when it comes to PC fans, increased complexity is not really an issue since it's just an electric motor. But the increased noise could be a problem. We're gonna have to look at that as we kind of test out the design and see if that's actually an issue. So let's start by testing the performance of this fan, and to do so I'm going to use an anemometer. This is going to measure the airspeed of a 3D printed bracket that I kind of made up that's going to take that 120 millimeter fan and bring it down to the anemometer fan diameter of 65.5. And then using that airspeed and then that diameter of 65.5, we'll be able to figure out what the airflow in CFM is. To simulate the air cooler's fan configuration, I also printed out a bracket that's going to hold the fans at the exact same distance that they are when they're mounted to the cooler. And then we don't have to have the fin stack or anything like that playing any part. It's just the fans, and we can test them by themselves and then together. And then I also threw in a bunch of other fans that I have around here just for some context, so you can kind of see how well fans of different brands and names perform versus these fans and then this configuration. So as you look at this list of all these performance numbers of all these different fans, you might notice something a bit strange. The Kaze 120 has a big DNF next to it, or did not finish. And the reason I have this is for whatever reason, when I mounted this fan on this bracket that I produced for this anemometer, I could not get this 120 millimeter fan to produce any decent airflow at all. Sometimes it would just be stagnant and couldn't get anything to flow through this. I don't know if it has something to do with the blade design of this particular fan in correlation to with my bracket or whatever, but the air wouldn't move through the ductwork. And this issue is only present on the Kaze 120. The Kaze 120 Slim mounted up and performed normally, just like all the other ones. And I even went as far as testing 3 other Kaze 120 fans that I have laying around, and every one of them did exactly the same thing. In fact, the only way to get air to move through the ductwork when having a Kaze 120 mounted was to put my hands slightly in front of the fan and kind of disturb that pressure zone that was forming, and then I could kind of get some airflow, but it was just very weird. I have some ideas on what might be causing it, but if you guys think you know what was going on here, make sure to leave me a comment down below. I'm kind of interested to see what you guys think, but very weird. When I stacked the Kaze 120 with the Slim and the Contra-Rotating configuration, I was able to get a usable reading. However, not having a baseline for the Kaze 120 meant that I wasn't able to validate how much or if any extra airflow was being produced by the Kaze 120 and the Slim, because I didn't have a Kaze 120 baseline to, you know how it works. And the Kaze 120 is like the only fan that spins in that opposite direction. All these other fans spin exactly how the Slim does, which is the standard normal PC fan spinny direction. So the jury's still out on that one. Next, I tested the stability of the airflow, and to do this, I used a super high-tech stability visualizer. Oh. This instrument is comprised of a sealed cardboard box with 2 holes cut in it and a fog machine. I also threw in an LED light because it makes things easier to see kind of against my garage door, and also RGB. Now, this is where things get interesting. The first thing I did was run each fan by itself. So I ran the Kaze 120, the 120 Slim, the NH-U12A X25, just to kind of see how they all performed, and you can really see that rotating airflow we spoke about earlier. However, when we throw the 120 and the 120 Slim in this reverse flow configuration, there is undoubtedly stable airflow with little to no rotation. Now, although I will agree this configuration does provide more stable airflow, keep in mind though, when you have this mounted on an air cooler, the fin stack is basically going to act like a flow straightener, and it's going to reduce much of that rotational airflow that the rear fan can take advantage of. But anyway, how does this all stack up for cooling? For my cooling tests, I did the standard 30 minutes of Prime 95 on my i5 2500K at 4.5 gigahertz, and I ran 4 tests, 4 different configurations. I ran the standard reverse flow configuration that, basically how the cooler comes out of the box. And then I took away the Slim and I ran a dual Kaze 120 configuration with basically both fans spinning in the same direction. Then I ran that again with just a single Kaze 120. And then lastly, I put the dual fan reverse flow, so the Slim, the normal Kaze 120, and then I threw on an additional Kaze 120 on the backside, so like a 3 fan configuration, just because they give you the brackets and I want to see if you got any extra performance by doing this. And across the board, every configuration, except for obviously the single fan configuration, performed almost identically. Also, even if you look at just the single fan configuration, the temperatures produced were still looking really good. Looking at 66.2 at an average, which is very respectable. And it just goes to show how well optimized this cooler's design is. Although I couldn't validate the increased airflow claim and the benefits of contra-rotating blades is going to be hindered by the fin stack in between them, there's much to be said about this configuration. Because the 120 Slim is only 15 millimeters thick, and the cooler is asymmetrically designed, there's going to be literally no limit to how tall your RAM can be, because the The fan never hangs over your front dim slots. Also, the straightening of the airflow as it flows through the fin stack means that these fan blades can spin in opposite direction without any additional noise. So in the end, if you're looking for a great performing air cooler and don't want to risk any possible issue with RAM interference, and you want something that just looks good, the Kuma 2 is exactly what you're looking for. But I hope you found all these tests fun and interesting to watch, and make sure you leave me a comment down below if you think you know what was causing this goofy little phenomenon with this 120 and this printed ductwork, because it was very strange. But thank you for watching. Make sure to get subscribed, and we'll see you in the next video.